Yeah, everyone, just another video, last video on continuous random variables. Um, and so what we're going to look at today is linear transformations of CRVs. So when you've got, if you've got a random variable x, and if you any like 3x plus 2 or something like that, just some linear transformation. So multiplied by a number and then added or subtracted a number, so a linear transformation. Now these are exactly the same as DRVs, exactly the same formulas, and they're written there in front of you. If you've got the expected value of a linear transformation of x, all that happens, and it's like I explained with discrete ones, the a comes out the front multiplied by e to the x plus b. And when you do examples of that, it just totally makes sense that, of why that's true. Variance is not so clear, but the same formula as discrete. The variance of a linear transformation of x, the coefficient of x comes out the front as a squared, and b is not part of the calculation for the variance. It doesn't matter where it is, left or right, in your probability distribution. The variance isn't affected by where it is. It just matters how wide everything is. So they're the two formulas, and they're the exact same formulas as in discrete random variables. So just a quick example, just to make sure you remember all this stuff. So I've got a CRV x, and it's got an expected value of 3. So I'll just remind you that mu means the expected value, so that's ex there, and a variance of 2. So variance x equals 2. We'll just write it. So I've got that information. So e to the 2x plus 1, using that formula up above, that's 2 times the expected value of x plus 1. That's 2 times 3 plus 1. Let's get back to year 5. Very good. 7. Sorry, I shouldn't be nasty there. So that's equal to 2 squared comes out the front, and then it's times by the variance of x. What was the variance of x? It was 2. So 4 times 2 is 8. Underline these things. Sorry, I'm flying through these. This one's a little bit trickier. E to the x squared, how do we do that? We can't do that. What we do know is that the variance of x is equal to expected value of x squared minus the expected value of x all squared. So we can use that fact. The variance of x, I'll keep scrolling down, is 2. So therefore 2 is equal to the expected value of x squared. That's what we don't know, and that's what we'd like to find out. Minus the expected value of x was 3. That's minus 3 squared. So therefore the expected value of x squared is equal to 2 plus 9 is equal to 11. Expected value of x squared is 11. So just using the formula for variance to rearrange there. Now I've got a linear transformation of e to the x squared. So that's equal to 3 times, I don't know what I did therefore, equals 3 times e, so it's a linear transformation of e to the x squared. That's still allowed, that's fine. And so that's equal to 3 times 11, which is 33. These are easy, aren't they? I hope you get some of these in the exam. And finally, this is equal to, again, that's a linear transformation of ex squared, so that's e to the x squared, expected value of x squared, take away 5, which is, what was the expected value of x squared? I've forgotten it already. 11, take away 5, which is equal to 6. So nice and easy. So that's just applying those linear transformation formulas up there. Just be aware of them. Can get you out of trouble. They're really easy to use, but sometimes you can forget how to do it, and the question looks more confusing than it actually is. Hope that makes sense. See you in the next video.